Welcome back everyone to the math video. You might be wondering, why am I not uploading that much? Well, my iPad time has been cut short. Anyways, today we will be learning about the Angleangle similarity theorem. Is when two sides of the triangle are the same, and with knowledge, this comes into play. Whenever two angles are the same, you will know what the third angle is. I mean, if you know two angles, then you know the third. So now let's do a math equation. You might have already known this, but 8th grade. So, pretend this side is 71. Pretend this side is 9. Now, with reasoning and of this similarity theorem, you'd add 71 plus 9, you get 80. Now, the total angle measurement is 180, so minus 80 off of 180, you'll get 100. And that is when 100. That's when this thing comes into play. As you can see, this thing is the equation. Angle similarity theorem means that if you have two angles that you know, the third angle is easy. Anyways, if you were to look at this, you only knew one angle. This thing would say that this thing is unfindable. You cannot find it at all. It's impossible. But if it was this, then it still comes into play because this is a 90-degree angle. Now, for this one, an exterior angle, this one is the same thing as this, but you're going to need to add another rule. That rule is in another video. So, if you were to know this angle and the exterior angle, then you would have to add the exterior angle rule, and this rule to get a total. This is plausible. So, if this was 41, this is 100. So, 180 minus 100 equals to 80, which means you know two angles now. Two angles. So, now you add these two equals to 121. I'm not writing it down because I just ran out of room. So, 41 plus 80 equals to 121. Minus them, you get 59. This angle, 59. So as you see, this is the angle similarity theorem. So now let's go to the next one, the corresponding angles. For this one, I usually do it like this way. These things are memories. There are transversals. So this thing in the middle is a transversal line. I mean, it's called a transversal in short. So these two are parallel lines. Okay. Parallel. Just wait 1 second. Parallel lines. So, these two are parallel lines, a transversal. Now, these are corresponding angles. For these things, if you were to cut here, they would be the same. There would be a T, a 1 and a 360-degree angle. Okay, so now, corresponding angles, you might be thinking. So, these are corresponding angles. Reason why is because these two are complete copies of themselves. They're not just similar, they are the exact same copy. So, this thing would be the same as this. This angle would be the same as this angle. This angle would be the same as this angle. But these two are known as alternate exterior angles. These two are the same line interior angles. These two are the same line exterior angles. These two, this one and this one, these are known as alternate angle exterior, interior angles. Alternate angle interior angles. So now, corresponding angles. This and this are corresponding angles. They will always have the same angles no matter what. Now, let's move to the next one. Corresponding sides. Just wait 1 second. Corresponding sides. Okay, the G's messed up. So, corresponding sides. Corresponding sides. So, corresponding sides. Alright. Okay, pretend these two are the same triangle. Corresponding side would work as this. This triangle, this angle is the same. So now let's put it in a term, in a value with, let's put it in a triangle with letters A, B, C. Okay, these are primes of this triangle, A, B, C. I won't do a video on this, but soon. So, if you were to know that primes are the exact same value as the original, their sides would change, or angles, most likely sides, but still. If these two are complete copies, then that would mean that this thing and this thing would always be the same side if the angles are changed. And A, B, C. If it's a this, also you gotta put triangle. The triangle is usually over here, but I have no space, and I'm going fast. So, the triangles, if they put this, or they do this, if they were to do these two, and if they were to do this or this, that would mean that these are the same shape, same size. They would be the same. Usually, actually, they could, these primes could also be different letters. But if the different letters match up with these, with this symbol or this symbol, actually, with these symbols, then they're exactly the same. Corresponding sides, or when two sides are the same, they are congruent and they are similar. They have to be those two. If one was smaller or larger, who wouldn't count as a corresponding side. So now, just wait. Anyways, so now corresponding sides. So these two are this is a corresponding side. This is a corresponding side. This is corresponding sides. This is corresponding angles. This is angle similarity theorem. If you didn't get any of that, just read the description. Anyways, so yeah, this corresponding angles, corresponding sides, and angle similarity theorem. You learned something today. See you again.